So today I want to talk to you about ocean exploration in general, but telepresence-enabled ocean exploration in particular. And over the years, I'm sure many of you have heard a number of lectures, not only by me, but by others at Harvard Branch about exploration and some of the products of ocean exploration, some of the results. There's a new paradigm for ocean exploration that involves telepresence. And so that's what I want to talk about today, because we have a new facility here at Harvard Branch that's going to be opened up for education and outreach activities, and there'll be some opportunities for the public to come in and use our Exploration Command Center. So I want to start first with some definitions about telepresence, exploration, robotics. So just to set the stage. And what I'm going to do is we'll have a mixture of slides and also some short movie clips as well to explain this whole concept of telepresence-enabled ocean exploration. So telepresence enables us to do something or be somewhere that we can't actually fit, where we can't actually physically be. You already have examples of that. If you've got, if you do FaceTime or Skype, that's telepresence. If you participate in webinars, that's telepresence. There's a really an older example of telepresence. First video, please.
With the Earth, it fired its engine to slow its descent to a touchdown on the near side of the moon.
Remember when this was?
Collins in Columbia continued in orbit, awaiting their return.
It's in 1969.
540
Think about this, about all the different elements that enable this telepresence mission to occur.
I'm going to step off the limb. That's one small step for man, one giant leap for mankind. Are you getting a TV picture now, Houston? Neil, yes, we are getting a TV picture. You're in our field of view now. Okay,
that's one small step for man, one giant leap for mankind.
Okay, so that's telepresence. It's not robotics. It was manned exploration, but it enabled millions and millions of people to participate in that event. Okay, we're going to go through the different steps of telepresence-enabled ocean exploration in a couple minutes. Another important element of telepresence-enabled ocean exploration is the use of robots and robotics, and these are just two examples. On the left-hand side is a remotely operated submersible, an ROV. It's tethered to the ship, so you can communicate in real time and transmit images and data in real time. On the right-hand side is an autonomous underwater vehicle, or AUV. And right now, the technologies are limited to enable communication through the water of a lot of the data that are collected by autonomous underwater vehicles. So as we talk about telepresence-enabled ocean exploration, I'm going to really focus more on remotely operated vehicles, because right now, that's the best that we have in terms of being able to communicate what the robot's seeing or collecting on the bottom in real time back to the ship and back to participants on shore. Okay, ocean exploration. Well, you all know what ocean exploration is. We've been doing ocean exploration here at Harvard Branch for more than 40 years. Our founders, Stuart Johnson Sr. and Ed Link, were passionate about ocean exploration. They founded this institution based on exploration of deep water environments, of truly integrative, interdisciplinary science and technology, being able to go out to sea, use advanced technologies to explore. Ocean exploration is about going places where we've never been before, or maybe going to the same places, but going there in a different way, or doing something different, or being able to use a different technology to learn more, to discover more about that particular area, and searching for the unexpected. It's disciplined and it's systematic. So none of the funding agencies these days are going to just hand over a pile of money and say, go and do something good with this, or go out and explore. We really have to have a plan in mind about what it is that we want to do. So it's very disciplined, it's very systematic. Okay, so I'm going to go through some of the steps for telepresence-enabled ocean exploration. What are the basic elements? First of all, you have to have a plan. And you have to have enough money to execute that plan. So it takes sometimes months or even years to plan an expedition. Just like NASA takes months or years to plan its exploration, and how it took years to send human beings to the moon, and we're starting now already and have been in the process of planning missions to Mars that aren't going to happen for at least a decade, maybe longer than that. So it takes a plan. You need to know what you want to do, where you want to go, and you have to have all your ducks in a row. You need to know how much money you need, how much it's going to cost, and you have to have that money available. You need to have a ship, at least for now. And the reason I'm saying at least for now is that as technology develops, it may eventually be possible for remotely operated vehicles or autonomous underwater vehicles, so untethered to a ship, to be launched from shore and to be able to go for hundreds or thousands of miles collecting data and images, transmit, and maybe even samples and transmitting those, at least the data and images, back to shore. But at least for now, you need to have the mothership. You need to have telecommunication capabilities. Now, all of the ships in what's called the academic research fleet, it's called UNOLS, the University National Oceanographic Laboratory System. There are 19 ships in that fleet. They're owned by, sometimes by federal agencies, but usually by universities. And the National Science Foundation spends about $75 million a year to enable scientists to go out and do oceanographic research. They're all equipped with satellite communication. But if you want to be able to transmit the amount of data that we need to transmit when we're trying to do telepresence-enabled exploration, you need to have large bandwidth, powerful satellite communication capabilities. Robots, cameras, and other sensors are needed so that we can collect the images and the data so that it can be just like we're there. You need to have a process so that you can collect those images and data and then be able to send them back to shore in real time or near real time. Because if you want to participate and we want to be able to communicate with what's happening out at sea, you need to have that information in real time. You need to have on board the ship scientific and technical expertise to make decisions about what to do. To be able to determine on the spot, is this something we need to abandon at this point? We want to move on further, do something else. And then you need people on shore who are interested in participating. You need a mission control, just like mission control at NASA. You need a mission control back on shore. But then you need at other different locations people who are interested in participating. And that can be in a variety of ways. It can be scientists who sit either at a specific, what we call Exploration Command Center, and participate as a group. You have the luxury of sitting at your desk in your office and being what I call a desktop oceanographer, and being able to get onto a chat room and communicate again in near real time. And I'll say near real time because it's not usually fast enough to be able to communicate in real time. And then also, one of the other ways that telepresence is used is for education and outreach. So Bob Ballard's group at the Ocean Exploration Trust have a variety of exploration command centers set up in a number of schools around the country, and I think maybe even around the world, so that students can participate in this as well. And then you need the capability for the participants on shore to communicate in near real time with the science leads. And I say that because this is different. It's not like expeditions that you might be more familiar with, where you have a crew of scientists and technicians and students go out to sea. Here on these expeditions, you only have two science leads, usually a biologist and a geologist. And the rest of the crew are technicians, satellite communication specialists, ROV operators, who are making sure that all of the other elements for a telepresence-enabled ocean exploration can happen. So it's quite a bit different from the types of missions of exploration that we're used to. Another important thing that's different from a lot of the oceanographic expeditions that we take are that one different thing is that the data are publicly available, so anybody can use the data that are collected on these missions. Okay, so let's go through it step by step. Ships with telecommunication capability. I just told you all of the ships in the academic research fleet have satellite communication capabilities. There are two and actually the Nautilus is a privately owned ship, so it's not part of the academic research fleet. It's owned by the Ocean Exploration Trust, which is headed by Bob Ballard. The ship on the left is the NOAA ship Okeanos Explorer, and both of these ships are specifically dedicated to ocean exploration. That's all that they do. And they've got enough satellite communication capability and bandwidth so that they can communicate video, images, videos in real time, data, sonar images, and so forth. So we have 2 ships right now that are specifically focused on telepresence-enabled exploration. On the Okeanos Explorer, which is NOAA's ship for ocean exploration, there is a remotely operated vehicle called the Deep Discoverer that will have the capabilities to go to 6,000 meters, which is pretty deep. It's tethered to the ship, and so it can communicate in real time data and images. There may be specialized sensors on board the ship, and so on the Okeanos Explorer, there's what's called a special type of sonar called multi-beam sonar. And each night, and actually sometimes for a couple of weeks before the ROV operations, the remotely operated submersible operations start, there are mapping operations. So the ship goes back and forth over the bottoms and puts together a very detailed maps of the bottom so that we know where to go with the robots. Okay? That is not communicated in real time back to people on shore. You have to wait for the data to be processed. I don't think it's communicated in real time. Okay, there's a shipboard control room. Got lots of monitors so that the science leads, the ROV operators, technicians can control what's going on, both on the ship, but especially with a remotely operated vehicle, or when they're doing the mapping operations at night. Stephanie's not here, right? She would die a thousand deaths if she knew that I was showing this picture of her. But I'm really proud, and I have to brag on Stephanie. So this was the crew for the last April's Okeanos Explorer expedition. And there's Stephanie, and that is the other science lead there, Jamie Austin, who's a very experienced geologist. Stephanie was invited, and Stephanie is a marine scientist, research assistant who works with John Reed. She was invited to be the biology co-lead on board the expedition. She did a fantastic job. I think this might be the first time that they invited someone who's not a PhD to be a science lead. And Stephanie did a fantastic job. So I'm very proud of her. Okay, so that's the shipboard expertise. And then shore-based participation, if you're doing it in a group, we here have an exploration command center, which consists, again, of tech panels or video monitors, and then smaller video monitors, computer monitors. And you can see Dennis and John Reed and Josh Voss and Kristen. There are a number of scientists, students, technicians who participated in the April expedition. Let's see what else. Okay, this next video is an interview that we did with one of the science co-leads on board the mission that happened in October to the northwest Atlantic, some canyons, and also with one of the NOAA leads who is responsible for organizing the expeditions. So you'll see an interview that I did with Brian Kennedy, who's a NOAA Corps officer, and Scott France, who was one of the science co-leads. Okay, video, please.
Hello, and welcome to the Exploration Command Center at Florida Atlantic University's Harbor Branch Oceanographic. Nice to have you here today. I'm Scott France, and this is Brian Kennedy, and we are standing in the ROV control room on board the NOAA ship Okeanos Explorer. We're about 200 miles southeast of Cape Cod, beginning to dive with the ROV to a depth of 2.5 kilometers.
So what you're seeing right now is the control room on America's ship for ocean exploration. This is really the nerve center of the vessel. Right now the ROVs are in the water descending on Physalia Seamount. The screens behind me you're looking at right now are the ROV pilots and what they're watching.
So the ROV is a remotely operated vehicle. It's essentially a robot of sorts, and it's being controlled by pilots and navigators here in this control room. We're sitting on the deck of a ship, and the ROV is descending below us to the sea floor. It has high-definition cameras on it that are able to transmit these just glorious images of the organisms that live on the bottom, the geology of the bottom, transmits them up the ship, and then the ship has a satellite that can beam them to shore, and then it goes out to the Exploration Command Centers, the ECCs, like the one that you're in right now. We also have a group of scientists who are located in institutions in ECCs like you're standing in, and also other institutions, other ECCs around the country. We can even have scientists from around the world that are collaborating through an instant messaging system, something we call the event log. And so the scientists like myself and Susan Schnorr, our geologist on this leg of the cruise, have our laptop computers and are constantly monitoring and having an exchange with the scientists on shore, making observations of what we're seeing in real time out here on the ocean. And in this way, we can collaboratively better understand what we're seeing. We can have guidance from the scientists on shore who may be interested in certain features that other scientists may not be. It's really good input and make sure that we don't miss anything, that we can use the capabilities of the ROV and the vessel to its maximum. Over the last couple of weeks, we've been on the third leg of this expedition that started in early August. We've been exploring canyons of the eastern seaboard. It's really interesting that we're just at some points maybe 60 to 70 miles off some very densely populated shorelines. New York City, for example, we're investigating canyons. Huge canyons. We're not talking about small features, but canyons on the scope of the Grand Canyon that are undersea that have never been explored before. And so it's really fascinating to think of these features, these undersea features that are so close to a lot of people, but we don't have any understanding of them. And so these are the first explorations of these features.
A question might come up: what is the value of ocean exploration, especially when we're dealing with such large issues related to the economy of the United States? Why are we investing into a ship that's dedicated to explore the ocean?
Well, I think the immediate answer is how do you manage, conserve, or utilize something you don't know or understand? We have a huge submerged America we know very little about. The United States controls more seafloor inside our exclusive economic zone of any other country. In fact, there's actually more seafloor in the United States than there is land area. And we know so very little about it. Our job is to go out and collect that baseline characterization.
So about 5 years ago, we received an award from the National Oceanic and Atmospheric Administration. In fact, the program office that is responsible for the Oceanus Explorer, the ocean exploration vessel. And we're a cooperative institute. I talked about the cooperative institute in previous lectures. It's a consortium cooperative institute. Our partners are University of Miami, University of North Carolina at Wilmington, and SRI. And we have three specific themes. One is to explore that outer continental shelf edge, those frontiers, really along the whole east coast of the United States and into the Gulf of Mexico. We're focusing off the coast of Florida because of, quite frankly, of funding constraints. Another mission is to study vulnerable coral ecosystems, and I'll talk in a couple minutes about how we're discovering deep coral reefs and using the information that we're collecting to be able to expand the protection of those coral reefs. And also to develop advanced undersea technologies to help us to increase the pace and scope of exploration. So in last April, the Oceanus Explorer was working in the Gulf of Mexico, and that was the mission under Stephanie Barrington was the science co-lead. And went into the planning of that mission, a number of scientists who were interested in exploration in the Gulf of Mexico got to submit requests for dives, so that it's not just the NOAA making these dives. The scientists actually can control which the places where we want to go and the types of dives we want to make. So we requested some dives in an area on the west, what's called the West Florida Escarpment or the West Florida Shelf, because John Reed and his group have been working in that area for many, many years, and we were really interested in doing more mapping of that area and more exploration of that area using the remotely operated vehicle. In that area, there's a very long wall, or it's called an escarpment. It extends over 100 nautical miles, and it's at a depth of about 500 meters, and it runs from about Naples south to another area along the southwest coast of Florida called Pulley Ridge, and I think you've probably heard about that in the past as well. So the wall is very steep. It can be about 30 meters high in some places. That's about 100 feet high. It's got corals, gorgonians, and sponges, of course. And some of the first information that we had about this area was done a little more than a decade ago by scientists at the University of South Florida. And so there have been repeated studies in that area, and the U.S. Geological Survey as well. But there have been repeated studies of that area, but we really needed to do something more methodical. So, yeah, why don't we go ahead and show that. This is a highlight video that was put together by NOAA about these West Florida shelf Ophelia coral reefs.
It's the most exciting thing in the world to see a piece of seafloor no one's ever seen before. This is certainly more what I was expecting along this, along the tops of these features all around, but this is the densest Lophelia concentrations we've had.
Yep.
This is dive 15 of the Okeanos Explorer. We're at a water depth of 540 meters. We're on the top of a bioherm on the western part of the Florida shelf near the top of the Florida escarpment. The bioherm is a mounded accumulation formed from the skeletons of all that's been living there. So it'll just be a cemented mound of things. It could be corals, it could be algae, it could be bryozoa, whatever has lived and died there over time. Now we're up on top looking at deep water coral concentrations and related biology on these biohermal or these biological buildups. In fact, these buildups are sitting on old carbonate blocks. There it is. They call that the golden crab. Chasion finneri. This is one of the major objectives of our dive today, is do a census of the crabs that live here in proximity with the corals, measure some sizes. This is a commercially important crab in this part of the Florida shelf. Amazing amount of rubble here. It's amazing. It's got to be thousands of years old, some of this stuff. And as we were talking about with the carbonates on the escarpment, the darker staining is an iron manganese coating. It's indicative of the amount of time that the material's been in contact with seawater. A lot of this rubble is pretty dark.
Okay, let's explore. One of our visitors has a question for you, if you don't mind.
Sure.
Hi there. I was actually just curious what kind of fish that is that you're looking at right now.
It's a type of scorpion fish. Tracheoscorpia. Crystallata is the genus and species. They hang out on the bottom. They're ambush predators.
Yeah, they hang out very motionless on the seafloor, even when confronted by a 4-ton ROV.
Look at all this standing dead coral.
Yeah, there's a lot of debris. Really nice edge here. We've been diving on the Florida escarpment the last couple of days, and today we're up on top on the western part of the West Florida shelf, but we're still seeing a little bit of Florida escarpment carbonates under these bioherm, these biological buildups that these carbonates are sitting on.
So what do we do with all of this information? Why is it so important? Why were we so interested in spending some time on the West Florida shelf? Why are the reefs important? Why do they need to be protected? These are habitats for a lot of commercially important species, and John Reed's group has actually documented incredible destruction of oculina corals on the east coast of Florida, and we're really concerned about the same thing happening over on the west coast of Florida. They grow very, very slowly. They're really fragile. A single coral mound can be from 100 to thousands of years old. So they really need to be protected. As I mentioned before, the Oculina coral mounds have been, some of them have been completely destroyed because of bottom trawling for shrimp. You saw images in the video of the golden crab, and these are very common on the Lophelia reefs. And the way they're fished could also just destroy the very reefs on which they depend for their habitat. So it's important to be able to document this information, to be able to present the data, have adequate documentation so that you can go to the appropriate fisheries management councils and request increased protection. As I said, John Reed and his group have been working on this for many, many years. These are some multi-beam sonar images of that area. This one is the area where dives were made in 2003 with the ROV, and then in 2010 we made dives with the Johnson Sea Link sub, and again out here in the deeper area in 2010 with the Johnson Sea Link, and these are areas in 2014 that the Oceanus Explorer dove with the ROV. Okay, so what do we do? And I just wanted to show this other video because this is a video that was taken during that expedition, but in our Exploration Command Center. So John Reed, Dennis, Josh, Michael, all the scientists and students who would normally have gone out to sea to work in this area, and it could have been with an ROV, but also all of us sitting in an ROV control van, are now sitting right, let's see which way, that way, in a room, and being able to see all of this in real time. So I'm going to kind of talk you through what's happening in the Exploration Command Center. Okay, so again, we have a few tables, desks. You can see John, and I think that is Josh there now, looking at that area, looking at the map, and you can see the images. The 3 video screens are exactly what you would be seeing up on the Oceanus Explorer as well. So you can actually see what the ROV is taking videos of. We had students, research assistants who were logging data, who were capturing, that's Kristen there, capturing some images so that we can have still photographs of some of the more interesting things that we observed. There's Dennis. Again, it's a really great teaching tool as well because it enables us to involve more students than we would normally be able to take out to sea with us. And what was done with all of these data, so not only the data that were collected during that expedition back in April, but also going back, I guess, more than 10 years, was a proposal that was made to the Gulf of Mexico Fisheries Management Council. John Reed from Harbor Branch, Peter Ettenroyer, a NOAA scientist, and Sandra Book, a scientist from Florida State University, submitted a proposal to the Fishery Management Council to expand the West Florida shelf, Lophelia coral. HAPC is habitat area of particular concern, and EFH is essential fish habitat in the eastern Gulf of Mexico. The data I mentioned are publicly available, so any of you can go on. You can just go on to, say, Digital Atlas, Google Digital Atlas, and you'll get the NOAA website. And you can see all of the areas where missions of exploration have occurred. Not just these are from many years. You can search by year. You can search by theme. So if you're interested in something that was more in terms of biodiversity, you would just see where the missions were. Then you click on that dot, and you can get data about the expedition and data that then you can use for your scientific research. I want to show you, I think, just one more video because another interest in this particular mission was maritime history and marine archaeology. There were no marine archaeologists on board the ship, but they submitted plans for areas where they wanted to explore in this area and look at what they thought were potential shipwrecks that they had observed. And they had observed these targets from previous missions that were run and multi-beam sonar maps that were done on the bottom. So they identified areas where they wanted to go back and do some more in-depth research or exploration, I would say at this point. And so this one, okay, Jill, you can go ahead and start that anytime. I think it was rough that day. This is back
For all
in
of you
April.
out there, this is the Okeanos Explorer. We are starting Dive 7. Today we are looking at a shipwreck, what we call Monterey B. It's the third in what we think may have been a fleet of 3 ships that all sank together and somewhere in the early 19th century.
This is the only of the 3 ships that isn't clad in copper. But it
also
also seems, ironically, to be of the 3. The starboard side seems a little more exposed, but then there's also a bulkhead towards the aft quarter of the vessel. And there was some question about what appeared to be a mast, but it seems to be a little off-center.
Everybody, take a look at the staining. You can really see the form, the lines of the stern here. Look here and you can see the edge of the planking, frames underneath. I believe this vessel has heeled over.
Does that look like it's sitting inside of another bowl?
It could.
It almost looks like it, huh?
Could be.
So this wouldn't be an hourglass. This would probably be a minute clock. These would come in seconds and minutes in their navigation.
Ah, great. Thank you.
You see the gimbal, and you see the remains of the box. This, if it's not the compass, this may be what's left of this ship's chronometer. I'd like to look at the edges of them. One of the things that you sometimes will see is where they had laced and stretched them. But again, we just don't know a lot about the transport of these types of commodities. As you approach the bow, what we're going to want to do is take a look at the anchor, not only the form of the flukes, but also the stock or the body.
So again, this
We are diving
on Monterey B. This is the third vessel in a fleet of vessels that may have sunk together in the early 19th century.
So who's sailing around in softwood, possibly pine-built, 2-masted, unsheathed, iron-fastened vessels in the early 19th century?
And then they don't answer that question. I don't know, really. Okay, so let me recap a little bit. Of course, there are advantages and disadvantages with well, pretty much anything that we do. What are the advantages of telepresence-enabled ocean exploration? You have a broader engagement in the expedition, for sure. So in this particular case, it was an expedition that lasted about 3 weeks in the Gulf of Mexico. There's no way that you would have been able to put archaeologists, geologists, physical oceanographers, chemical oceanographers, biologists on the ship at one time. And so it involved a much larger group of scientists, or what we call doctors on call, or doctors on shore, to be able to participate. In addition to that, we could involve our students and the general public. So anybody at all could log in. You have different levels of access. So not everybody can call in and ask a question. You have to be logged in, registered, and really have a scientific need to be involved in that. Although there are times that they set aside specifically for students to be calling in as well. It enables us to increase the pace and scope of discovery because, again, you've got a lot more people involved, and it provides a stimulus for innovation because you think, oh, gosh, if only I was able to do that or had this particular tool, I would be able to do a little bit more. Okay, so what are the disadvantages? Smaller at-sea science participation. I love to go to sea. I get seasick, I still love to go to sea. I still love to go to sea. But, you know, for example, there's a mission that's coming up to an area that I've always wanted to explore. I'm not going to be able to do it, but you know what? I'm going to be able to do it using the Exploration Command Center or even sitting in my office if I'm not anywhere near the exploration command center. Technology doesn't really always simulate the actual experience. I think that we old-timers have kind of an edge on in one respect, because we've had the opportunity to go down to actually be in that environment. So even though I can't kind of look around and see what's behind me, I kind of know from the dozens of times I've been in a sub, for example, say, can we take a look and turn around, because we always, there's always something kind of over our shoulder that you can't really see with the ROV. On the other hand, our young scientists, our students, have grown up doing things virtually. They're used to that way of interacting with the world, and I'm not. So in a way, we complement each other. I think we're teaching and learning from each other. Something that's really important to us when we go out to sea, and when I say us, I'm thinking more about the biomedical group, is that we really need to have samples, be able to collect samples. Right now, the ROV on the Oceanus Explorer does not stop and collect samples. They don't want to stop and take the time to do that. And there have been many times when I've been asked, well, what is that sponge? It's like, I have no idea. It could be one of 5 or 6 things. Can you get me a little piece? And I'd be able to tell you. But, of course, we can't. So that's really a stimulus, again, for innovation. What can we develop? What can we invent that's going to, what can we adapt from other disciplines that will enable us to do maybe in situ analyses, be able to, or collect very small samples. So that, again, it's a stimulus for innovation. All right, where are we going next? There are 2 missions coming up that NOAA is sponsoring on the Oceanus Explorer. They're beginning actually at the end of February, and the ship is going to be leaving its home port in Rhode Island and traveling down the East Coast and doing some mapping, so that like this. These are multi-beam maps. Some more detailed multi-beam maps along the east coast of the U.S., but actually more along these Caribbean trenches and seamounts. And they're going to spend most of the time at this area called the Puerto Rico Trench, which is the deepest part of the Atlantic Ocean. It's more than 5 miles deep. And the leg of the mission that's going to have ROV operations will be from April 9th till the 30th. So that'll be a time when, if you're interested, you might want to log on to the Ocean Explorer website and be able to see what's going on in near real time. And then just after the ship is finished in the Caribbean, you're going to be heading over to the Northwest Hawaiian Islands and spending from July to September looking at the Pacific monuments and sanctuaries that are in the Northwest Hawaiian Island chain. So this is actually a chart of the Northwest Hawaiian Islands, and this little crisscrossing here, that's the level of information that we have in terms of mapping that area. And so one of the goals of this upcoming mission is to fill in all these white spaces so we know more about what the bottom is like in the Northwest Hawaiian Islands. And they're specifically interested in, I am going to murder this name, Papahanaumoku'ea. I had a friend of mine from Hawaii spell it out for me phonetically today. I was like, it'll just flow off your tongue, but it doesn't. Anyway, that's a marine monument. It's actually larger in area than all of the other national parks and monuments in the United States. So we're particularly interested in studying that area as well. So there will be public programming that will be available during both of these missions. We're working on that right now. In fact, Jim Masterson's going to be putting something together. And we're going to have some public programming that will happen during both of those missions so that anyone who's interested will be able to come and actually see what's going on in real time. So stay tuned for the details. I'd like to thank my fellow explorers, the old-timers, Dennis and John and Amy, Kathleen, I think, is in the audience. The newbies, the young up-and-coming scientists like Josh and Michael and Stephanie, and I know there are others in the audience, who are we're learning from each other. So it's been a great trip. I also want to thank John especially because John helped me a lot with the videos, with the images, with kind of reminding me about what he's been doing in terms of protection of the coral reefs. It's been, and the work that you're doing, John, is extremely important, and it's a great reflection on Harbor Branch, the protection of these areas that you've been able to accomplish with your dedication over decades. So thank you in so many ways. I also want to thank the Johnson Sealing crew and the crews of the Stuart Johnson and the Edwin Lane. That's where we learned to be explorers. The Oceanus Explorer team leaders are Brian Kennedy and Kelly Elliott. One of them, I think Brian's going to be on the Caribbean trenches expedition, and Kelly Elliott's going to be in charge of the one in Hawaii. She got a good deal there. And then, as always, I want to thank Brian and Jim and Jill for their assistance in helping me put this together today. Our funding comes from NOAA, and it goes through the Cooperative Institute for Ocean Exploration, Research, and Technology, which is that, SEORT, and Harbor Branch also provides support. If you want more information, here are the websites that you can link onto. You just remember Ocean Explorer or Exploration Now. And if you Google either one of those, it'll take you directly to those websites, and you can get more information. You can see the videos that I showed you because several times during the expeditions, highlight videos are prepared, so you can actually see these videos. You can download them as well. I encourage you, if you're interested in it, to check out these websites. So again, just Ocean Explorer or Exploration Now, and you'll be able to get more information. And again, stay tuned because we'll have some programming during the upcoming missions. Thanks very much for your attention. Thanks for coming, and I'd be happy to answer any of your questions.